When given two sides and an angle in a triangle, it turns out that those two sides and the angle don't necessarily make a triangle. There are three things that can happen, and there are a lot of conditions under which this can happen. And this chart I'm about to talk about may seem a little confusing, but I'm going to give you a very simplistic way to go about determining how many solutions a triangle has given two sides and an angle. The first four, the first four are all cases under which the angle that I give you is less than 90 degrees. So if side A is less than side B and angle A is less than 90 degrees, you're going to have no triangle if side A is a smaller value than B times the sine of angle A. It's going to give you one triangle if side A is equal to B times the sine of angle A. And there's going to be two solutions if A is greater than B times the sine of angle A. If you have an angle that's less than 90 degrees and side A is greater than or equal to B, you're only going to get one solution. But what if instead of dealing with an angle that is less than 90, what if the angle I give you is greater than or equal to 90? There are only two things that are going to happen. You're either going to get no solution or one solution. So if side A is less than or equal to B, you're going to get no solution. If side A is greater than B, you're going to get one solution. The way the textbook is going to do these problems is different from the way I'm going to do these problems. The way I'm going to do these problems is a way that organizes the information to make it easier for you to determine how many solutions there are given an angle and two sides. So I'm going to start by giving you angle A is 63 degrees, side A is 18, side B is 25. If you refer back to that chart, since angle A is less than 90 degrees, you could get 0, 1, or 2 solutions. This is how you're going to do it. You're going to set up a chart. Remember the chart? Same chart. So we're going to write A, B, C, and little a, little b, little c. And you're going to start by putting in the given information. So you were given angle A, you were given side A and side B. Using the law of sines, you're going to only be able to find angle B first. And we haven't talked yet about how to use the law of sines to find an angle. It's going to require us to do one additional step than we did in the previous section. Now, what's going to end up happening later on is you're actually going to always set up two charts. And the reason you're going to set up two charts is for the possibility that there could be two solutions. The thing about two solutions is if two solutions exist, they will have the same given information. So let's just start over here and try to figure out what B is. The way the law of sines works is you need to know an angle and its corresponding side. So I know angle A and side A. So the sine of angle A over side A is going to be equal to the sine of angle B over side B. Still a proportion, so I'm going to cross multiply. I always like to multiply what's going to give me my variable on the left first. So 18 sine of B is going to equal 25 times the sine of 63. And then we're going to divide both sides by 18 so that this goes away. So this is what you're going to do now. You're going to plug this part into your calculator. Then the answer that you get, which should say on your calculator 1.237509061, leave it. Do not write it down as a rounded off decimal. We're going to leave that number in our calculator because the next step is to solve for B. You have to do the inverse sine of that. So to do the inverse sine, you're going to hit second sine, and then you're going to hit second negative. And now what should have popped up on your calculator screen is A and S. that means previous answer. We've used it before, but it's probably been a while. So I want to take the inverse sine of 1.237509061. And when you hit enter, you get an error message. You didn't do anything wrong. Now, if you remember from the unit circle, I had told you that all the ordered pairs on the unit circle were cosine comma sine. So at 0 degrees, the cosine is 1, the sine is 0. At 90 degrees, the cosine is 0, the sine is 1. At 180 degrees, the cosine is negative 1, and the sine is 0. And at 270 degrees, the cosine is 0, and the sine is negative 1. And then when you get to 360, it just repeats itself. Well, the sine values are fluctuating between 1 and negative 1. And we wanted to take the inverse sine of 1.237509061, which is bigger than 1. You can't take the inverse sine of a number that's bigger than 1 because all the signs will always give you outputs between 1 and negative 1. So any number that's bigger than 1 or smaller than negative 1, when you try to take its inverse sine, will give you an error message. We call this no solution. The nice thing about no solution is you're going to know right away. You're going to go find your first angle, and it's going to give you an error message in the calculator. And that's how you're going to know there's no solution. If the original angle I give you is bigger than 90, then only one of two things can happen. It can either be one solution or no solution. So if you make your chart, how are you going to know if it's one solution or no solution? Well, you're going to go use the law of sines to find angle B. So the sine of 105 over 73 is going to equal the sine of B over 55. And we're either going to get an error message or we're going to get an output. And if I get an output, there's one solution. 73 sine of B is going to equal 55 sine of 105. I'm going to divide by 73. And then we're going to take the inverse sine of that answer. You actually can plug this into your calculator the way you see it. You can hit inverse sine, and then it opens a parentheses, so just do 55 sine of 105. Make sure you close the parentheses on the 105 before you divide by 73, and you'll get the answer of 46.7 degrees. Since I got an answer, there must be one solution. Example 2, find all the solutions for each triangle. If no solution exists, write none. So here in part A, remember I said if you start with an angle, if I give you an angle that is bigger than 90, right away it's either going to be one solution or no solution. So I'm going to set up my chart. I'm going to put in my givens. I'm going to notice that the first thing I have to find is angle B. There's no other choice. So the sine of 98 over 39 is equal to the sine of B over 22. And then I'm going to cross multiply. 39 sine B is equal to 22 sine 98. I'm going to divide by 39. And then I'm going to do the inverse sine of 22 sine of 98 over 39. Again, when you plug this into your calculator, remember that when you do the sine of 98, you have to close the parentheses before you divide by 39. And when I plug this in, my calculator spits out about 34 degrees. Well, now that I know that angle B is 34 degrees, the next thing I'm going to find is angle C. I don't have any choice. I can't find side C until I know angle C. And since I know all the angles inside a triangle add up to 180, I'll subtract both of those from 180 to find out that angle C is 48. And now that I know angle C is 48, now I can find side C. So the sine of 98 over 39. Now I'm going to set it equal to the sine of 48 over C. C times the sine of 98 is equal to 39 sine of 48. I'm going to divide by the sine of 98 to make it go away. And now I'm ready to plug that in my calculator. And I'm going to get C is approximately 29.3. It's not degrees. Remember, when you find the sides, you're not finding degrees. And the other thing I want to remind you is, notice that the biggest angle corresponds to the biggest side, and the smallest angle corresponds to the smallest side. If the original angle that I give you is less than 90, we have to fancy the possibility that there will be 0, 1, or 2 possible solutions. So I'm going to make 2 charts. The 2 charts will have the same given information. So I'm going to start with 72.2 degrees. Side A is 21 and side B is 22. So, same as before, the first thing we're going to do is we're going to find angle B. So the sine of 72.2 over 21 is equal to sine of angle B over 22. When I cross multiply, I get 21 sine of B is equal to 22 sine of 72.2. I'm going to divide by 21, and then I'm going to do the inverse sine of that. And I'm going to get an answer of approximately 85.9 or 86. We'll call it 86. All right, so here's the deal. How do you know there's going to be a second solution? Well, where is 86 degrees on the coordinate plane? Well, it's over here somewhere. We know that sines are positive in both quadrant 1 and quadrant 2. Well, in quadrant 1, all those angles are acute because they're less than 90. And in quadrant 2, they're obtuse because they're between 90 and 180. So the reason a second solution could occur is because the calculator only gives you answers in quadrant 1 or 4 when you do an inverse sine. For triangle problems, you will always be taking the inverse sine of a positive number, which means you'll always get a first quadrant answer. You will never get one in quadrant 4. So if you come back up here, if a second solution exists, then there must be an angle also in quadrant 2 with the same reference angle. Well, this is the reference angle. So all you have to do is 180 minus 86. That's going to tell you the quadrant 2 angle, which is 94. As long as these two numbers do not add up to be more than 180, then the second solution exists. What can happen sometimes is if you go and you try to find a second solution, you'll get an answer for B such that when you add A and B, it adds up to be more than 180. But you can't have 2 angles that add up to be more than 180 if 3 angles in the triangle have to add up to 180 exactly. So now there are 2 solutions. So the next step in both solutions is to find angle C. So I'll find angle C in the first solution by subtracting both of those from 180, and I'm going to find out that this is 21.8. And then in the second solution, I will also subtract 72.2 and 94 from 180 and find out that the third angle is 13.8. And then I will have to use the law of sines twice to find side C in each solution. So in the first solution, I'm going to use the sine of 72.2 over 21 is equal to the sine of 21.8 over C. C times the sine of 72.2 is equal to 21 times the sine of 21.8. I'm going to divide both sides by the sine of 72.2, and then I'm going to shove it in my calculator, and I'm going to get about 8.2. And then I have to go do the law of sines again for the second solution. This time I'm going to do sine of 72.2 over 21, but I'm going to set it equal to the sine of 13.8 over C. Remember, in these problems, you cannot use the Pythagorean theorem because they're not right triangles. So you have to use the law of sines twice. So I'm doing the same mathematical operations I was doing before. It's getting a little sloppy. I apologize. I'm going to plug that in my calculator, and I'm going to find out that C is approximately 5.3. So these are your two solutions. And again, the reason why two solutions can occur, and it will only occur if the first angle you're given is less than 90, is because we know from the unit circle, and all students take calculus, that when you do an inverse sine of a number to find an angle, you're either going to get an angle in quadrant 1 or 4. But in the triangle problems, you'll never get an angle in quadrant 4 because those angles are too big. So we're always going to get a quadrant 1 angle. But the problem is sines are also positive in quadrant 2. So there's the possibility that there could be a second solution. The second solution will be 180 minus the first answer you got, because the first answer you got is a reference angle. Example 3. A group of contractors is constructing a 24-foot slide on a playground. The slide inclines 45 degrees from the horizontal. The access ladder measures 18 feet long. At what angle to the horizontal should the contractors build the ladder? So I drew a picture over here, and I'm going to call the left-hand side the slide, and the slide was 24 feet long. The slide was at a 45-degree angle from the horizontal. Side A, the other side, is your access ladder. If you've seen old-fashioned slides, a lot of them are plastic now, but the old-fashioned slides that I used to go down were metal, and so the slide and the ladder were both at an angle, so it kind of made a triangle with the ground. We want to find out at what angle the contractor should build the ladder with the horizontal, so we're looking for angle C. The reason this is a law of sines problem is because in order to use a law of sines, you need to know a side and its corresponding angle. And I do. So the reason I called this triangle ABC was to help us see what sides and angles we were working with. So I know angle A and side A. I want to find angle C, but I know side C. So I'm just going to cross multiply. 18 times the sine of C is equal to 24 sine of 45. I'm going to divide both sides by 18. And then I'm going to put this in my calculator. I'm going to do the inverse sine. I should probably take this out. C is going to equal the inverse sine of 24 sine of 45 over 18. And the answer that it's going to spit out is 70.5. Now, why is it that that's the only answer? The reason there's not a second solution is because, so this is in quadrant 1, right? The quadrant 2 angle, who's got the same reference angle, would be 180 minus 70.5. So 180 minus 70.5 is going to be 109.5. Is there any way possible that that ladder could have a 109.5 degree angle with the horizontal? Well, no, because the slide, when you have the slide and then the ladder, it has to be an acute triangle. You can't have an obtuse triangle where, here's the slide. Can't have, this is the slide, and then this is the ladder over here. That would be one crazy ladder to climb up, wouldn't it? And it'd probably make the slide tip over. So remember, when you're doing these application problems, think about the problems logically. Just because I taught you that there's the possibility of having a triangle with two different solutions doesn't mean the real world application would make that true. In this particular problem, you have to be working with an acute triangle because otherwise the ladder wouldn't stand up and hold the slide. Otherwise you'd get this picture, the crazy slide. And that is the ambiguous case of the law of signs.